Now if we make use of these two relations, we get P, that is momentum, is equal to h over lambda, or we can say wavelength, that is lambda, is equal to h over P, where P is the momentum. Now de Broglie argued and he said that this relation, although for photon, but it is a general relationship. That means it is valid for material particle as well. That was his hypothesis. That was his guess. This relation must be valid for material particle also. So based on these two expressions, he gave his hypothesis. And he said this relation is valid for material particle as well. So we call this relation as de Broglie relation. That is lambda is equal to h over P. Now here lambda will be referred as de Broglie wavelength associated with the moving bodies, which we are calling it matter waves. And here P is the momentum of the moving body. So I repeat, so we have a de Broglie relationship, and that simply says lambda is equal to h over P. H is Planck's constant, P is momentum of the moving body, and lambda is wavelength associated with the matter waves, that is wavelength of the matter waves, which we are calling it de Broglie wavelength. Now we know from classical mechanics that kinetic energy of a moving body and its momentum are related. So we have a very simple relation, that is kinetic energy is equal to P square over 2m. So we can write momentum as under root 2m k E. So that's the relationship we can have, and we can modify our de Broglie relationship, and we can write, replacing momentum in terms of kinetic energy, that is lambda is equal to h over under root 2m k E. Now this is the basic relation that we'll be exploiting in numerical problem. So students are supposed to remember the two relations, that is, one is lambda is equal to h over P. This is de Broglie relation. P is momentum of the moving body, lambda is de Broglie wavelength, h is Planck's constant, and this momentum can be written in terms of kinetic energy. So this relation modifies to lambda is equal to h over under root 2m k E. So let's summarize the whole concept of matter waves. The concept of matter waves was given by de Broglie. De Broglie gave his hypothesis, that is the concept of matter waves, based on 2 points, that is, radiation has dual nature and nature loves symmetry. Matter waves refer to waves associated with any moving body. Now the de Broglie relation, the so-called de Broglie relation, is derived by making use of classical results from electromagnetic wave theory. Now in electromagnetic wave theory, we write the expression for energy as E is equal to hf, and momentum of electromagnetic wave is equal to energy of the wave divided by speed of light. When these two equations are solved, we get a de Broglie relationship. And what he said, that although this relation is for photon, but this relation must be valid for material particle also. So he proposed the relation as it is without any modification. Now let's move into other finer aspects of matter waves or de Broglie waves. The first point we have to understand that de Broglie waves are different from electromagnetic waves. We know fundamentally that electromagnetic waves are emitted whenever charged particle is accelerated or retarded. Now here matter waves are different from electromagnetic waves in the sense our particle or the moving body may not be charged. So that's a very simple indication that matter waves are non-electromagnetic waves. The second point that we have to understand, that the speed of matter waves is more than the speed of light, and we can derive this relation very simply. Now we know that speed of any wave, mechanical or non-mechanical, is given by a very simple relationship, that speed is equal to frequency multiplied by